Hello and welcome to the week 6 practice assignment solutions for the course Statistics for Data Science 2. So coming to the first question, we have been given that the joint density function of two continuous random variables x and y is given as f of xy is equal to kxy when x falls in the range 0 and 4 and y falls in the range 0 and 1 and it's 0 otherwise. We have to find the value of k. So as we know, the property of the probability density function is that when you integrate it over the full range of the random variables for which this PDF is defined, it becomes equal to 1. So we can write it as when we integrate from y equals 0 to 1, full range of y and full range of x also. What are we integrating? We are integrating the PDF kxy dx dy. It has to be equal to 1. And using this property, we can extract the value of k from here. So let's start integrating it. So first of all, we will integrate x here because x is inside here. So let's do this integration of x first separately. We are integrating x equals 0 to 4 kxy dx. So it will become ky x squared by 2 in the range 0 and 4. So it will become ky times 16 by 2. So it will become 8 ky, just 8 ky. Okay, so we can put it here and then we can integrate it with respect to y now. Y equals 0 to 1, 8 ky dy. So it will become 8k y squared by 2 between 0 and 1. So it will ultimately become 4k y squared. When you put y equals 1, it will become 4k. This is the value that we have got by integrating this PDF, but we don't know the value of k here. But we know that it will be equal to 1. So from here we can calculate the value of k, which will be equal to 1 by 4 or 0.25. So coming to the second question, we have been given two random variables x and y which have uniform distribution in some region D, and that region D is given as the set of all points x comma y for which x plus y is less than 4 and x and y both are greater than 0. And we have to find the value of probability that 2x plus y will be greater than 2. So let's try to see this situation graphically and then we will try to find the required probability. So we have been given the region where x plus y is less than 4. So first of all, what is x plus y is equal to 4? This is clearly a line. Okay, so x plus y equal to 4 is this line. Now the region D is the points where x plus y is less than 4. So x plus y less than 4 is clearly these points, but x and y both are greater than 0. So we cannot take points in this region, but we have to restrict ourselves to the region only within this triangle. Now we have to find the probability that 2x plus y will be greater than 2. So this probability that we have to find out must correspond to some region in our full support of D. Okay, so D is the set of all points where x and y can take any value. But among these full support, we have to find certain points where this condition is true, and we will have to find the probability that those values of x and y will be taken. So for doing that, let's also imagine what is 2x plus y equal to 2. So when you try to plot this 2x plus y equal to 2, when x equals 0, y is equal to 2, and when y equals 0, this is x, this is y, and when y equals 0 you will get x equals 1. So x will be somewhere around here. So we can do it in other color. So this is x plus y equals 4, and this is equal to 2x plus y is equal to 2. Okay, this is all the points. So, and we have to find out 2x plus y greater than 2. So this orange region is the required region that we have to calculate the probability for. Okay, so how do we calculate this probability? So we have to calculate the probability that 2x plus y is greater than 2. So generally what will happen, you have to add up the PDF or integrate the PDF for the full range of this x and y, okay, where you have to calculate the probability. But when you have a uniform distribution, what you can do, you can calculate the region where for which you have to calculate the probability divided by the area of the full support. Okay, in this case the area D, okay, area of the full support is equal to 4 half times 4 times 4, that is 8. And if we calculate the area of this required region, then we will be able to calculate this probability. But what we can do, we can write this probability, okay, in terms of its complement, 2x plus y less than 2. So this equality sign does not make any difference because these random variables x and y are continuous random variables, right? So now this area 2x plus y less than equal to 2 corresponds to this smaller triangle. Okay, so the probability for this area, okay, x and y falling in this region will be equal to the area of this small region, a small triangle that we can represent as A. Okay, this is the area that we are representing as A, and we can divide it by the area of the full support. So we can write area A by area D, and this will be the probability of this probability 2x plus y less than equal to 2. So the area A clearly is half times 2 times 1, that is 1. So we can write 1 minus 1 by 8, 7 by 8. So this is the probability that 2x plus y will be greater than 2. Coming to the third question, we have been given that the joint density of the random variables x and y is given as this: fxy of x comma y is equal to x plus y when x is in the range 0 and 1 and y is in the range 0 and 1, and it's 0 otherwise. We have to find the value of probability that x plus y will be less than 1. So let's first try to understand the situation graphically. So x and y, and x goes from 0 and 1, x goes from 0 and 1, and y also goes from 0 and 1. So this is the support of x comma y. So only within this range x and y takes any value, and what are the values that are taken? It is determined by x plus y. So we have to find the value of probability that x plus y less than 1. So what will be this? X plus y is equal to 1. X plus y is equal to 1 will be this line. It will clearly be a line. Okay, it's not quite a line, so maybe, yeah, reasonably good. So this is the line x plus y equal to 1, and we have to find the probability that it will be less than 1. So this is x plus y is equal to 1. So clearly you can see here that when you add x and y on this side of the line, you will find that x plus y is greater than 1. On this line it is equal to 1, and on this side it will be less than 1. So we will have to integrate the PDF within this region. And for integrating that, what we can do, we can consider some, okay, we can break the problem of integration and we can do it in this fashion. Okay. So what we can do, we can consider some small strip, any arbitrary strip, and we can do it from 0 to 1. So when writing the limits of integration, what we can do, we can consider x going from 0 to 1. You can imagine that it's moving. First it's here, then it's moving on the right direction. It's not fixed at a position, it is moving. And for this strip, for every such a strip, you are adding the PDFs or integrating the PDF. How are you integrating the PDF? That's a question. So this you can consider that it is at some arbitrary position x. Then for this point, what will be the coordinates? So even if we are considering it as a strip, we can consider it as just one point, because this strip we are considering as very, very thin. So we can write it as x comma 1 minus x. Okay, because x plus y is equal to 1, so y will be 1 minus x for whatever the value of x is there. So it means we are integrating the PDF in this small strip from y equals 0 to y equals 1 minus x. And what are we integrating? We are integrating the PDF x plus y. So first we will integrate with respect to y, because we have to integrate along the strip, vertical strip, and then we will integrate it in the x direction. So it means we are moving this and we are integrating it for all the strips. So let's do this inner integration first, and then we will put it there and find the outer integration. So this says y goes from 0 to 1 minus x plus y dy. So when you integrate it with respect to y, you will get xy plus y squared by 2 integrated from 0 to 1 minus x. So we can write it as x times 1 minus x plus 1 minus x squared by 2. So we can simplify this expression as x minus x squared plus 1 plus x squared minus 2x by 2. It will become 2x minus 2x squared plus 1 plus x squared minus 2x divided by 2. So minus 2x and plus 2x will cancel, and we will be left with x squared plus 1 minus 2x squared by 2. So we can put it here. X goes from 0 to 1 and we are integrating. 2 we can take out here, and it will become x squared plus 1 minus 2x squared. We are integrating it for dx. So finally we will get x cubed by 3 plus x minus 2x cubed by 3, and we will integrate it for 0 and 1. Okay, integrated between 0 and 1. So finally, if you do this, you will find it equal to 1 by 3 plus 1 minus 2 by 3. So it will finally be equal to 1 minus 1 by 3. So finally it will be 1 by 3. So this is the probability that x plus y will be less than 1. Coming to the fourth question, we have been given the joint PDF of two continuous random variables x and y. fxy of x comma y is 2 by 7, 5x plus 2y, where x falls in the range 0 and 1, y falls in the range 0 and 1, and it's 0 otherwise. We have to find the marginal PDF of x. So we have been given the PDF or joint PDF of x and y. We have to find the marginal PDF of x. So fx at x is something that we have to find out. So as you know, when we are trying to find the marginal PDF of any random variable, when we have been given the joint PDF, what we do is we integrate it over the other random variables. So in this case, there are only two random variables, x and y, and we are trying to find the marginal PDF of x. Then what we will do, we will integrate the fxy x comma y for all the values of the other random variable, that is y. So y goes from 0 to 1. Okay, we will integrate it over the range of y, and we will integrate it with respect to y. So we can write it as the PDF integrated with respect to y. 2 by 7 we can take it outside, 5x plus 2y dy. Okay. 2 by 7, then 5xy plus 2y squared by 2, that will become just y squared, and the limits will be 0 to 1, y equals 0 to 1. So it will be equal to 5x plus 1. So this is the marginal PDF of x, 2 by 7, 5x plus 1, and it will be in the range for the range of x. Okay, so this will be defined, this marginal PDF will be defined in the range of x. So the second option is the correct answer. So coming to the fifth question, let x and y be jointly continuous random variables with joint PDF. fxy at x comma y is given as k times 2 minus y, where x falls in the range 0 and 4 and y falls in the range 0 and 1, and the PDF is 0 otherwise. We have to find the marginal PDF of y. So we can find the marginal PDF of y by integrating the PDF with respect to x over the full range of x. But in this case, we don't fully know the joint PDF. A PDF we don't know because there is this k which we don't know. So we will have to first calculate the k, and then we can calculate the marginal PDF of y. But for calculating k, what we will have to do? We will have to integrate this joint PDF over the full range of x and y and equate it to 1. So what we will do? We will integrate y from 0 to 1 and x from 0 to 4. What we will integrate? We will integrate k times 2 minus y. First we will integrate it with respect to x, then with respect to y, and by the property of joint PDFs, this should be equal to 1. And from this equation, we will be able to find the value of k and then find the marginal PDF of y. So let's first integrate this. So for doing this, what I will do is I will calculate the inner integration first separately. So x equals 0 to 4. K we can take outside because it's just a constant. 2 minus y dx. So it can be written as 2x minus yx. X goes from 0 to 4. So k times 2 times 4, 8 minus 4y. So this is the integration, inner integration. We can put it here now. Y goes from 0 to 1. We can write it here. K taken outside. 8 minus 4y dy. Now when we integrate it, we will get 8y minus 4y squared by 2, that will be 2y squared. Y goes from 0 to 1. So finally it will be 8 minus 2, that is 6. But we left here k. So it will be, everywhere I left k. So it will be 6k finally. And it should be equal to 1. So it means the value of k will be equal to 1 by 6. Now we can put this value of k here in the joint PDF, and through that we will have the complete information about the PDF, and using this we can calculate the marginal PDF of y. So we have to calculate the marginal PDF of y, which we will be able to find by integrating over the full range of x. X goes from 0 to 4. What we will integrate? We will integrate k we can take outside, that is 1 by 6 times 2 minus y dy dx. Okay, we are integrating with respect to the other random variable. So 1 by 6, and here you will find it equal to 2 minus y times x. We will do it from x equals 0 to 4. Finally, it will be equal to 4 times 2 minus y minus 0. So it will be equal to 2 by 3 2 minus y. So this is the marginal PDF of y. So this corresponds to 2 by 3 2 minus y, and y goes from 0 to 1. Y will be in its range. So fourth one is the correct option. Coming to the sixth question, let x and y be two independent continuous random variables with PDFs fx of x and fy of y given as the following, and we have to find the value of probability that 2x plus y greater than 1. So we have to find some probability where x and y both are involved. Okay. So it means we will need to know the joint PDF of x and y for calculating this 2x plus y greater than 1. But we have been given this information that x and y are independent continuous random variables. It means we can find out fxy at xy by multiplying the PDF of x and y, because we know that the joint PDF of independent random variables is just the product of the marginal PDFs. So it will be equal to the product of y by 2 and 1. So it is equal to y by 2 when x is in the range 0 and 1 and y falls in the range 0 and 2, and it's 0 otherwise. So we have the information about the joint PDF of x and y. Now our goal is to find the probability that 2x plus y will be greater than 1. First of all, let's try to draw the support of x and y. So x goes from 0 and 1 and y goes from 0 to 2. So x goes from 0 to 1 and y goes from 0 to 2. So in this region, x and y takes values with the joint probability given as y by 2. So we have to find out the probability that 2x plus y is greater than 1. So first of all, we will have to understand which region does 2x plus y greater than 1 corresponds to, and then we can integrate the PDF or joint PDF of x and y in that region, and then we will be able to find this probability. So 2x plus y greater than 1, this region we have to find out. So first of all, let's try to see what is 2x plus y is equal to 1. So when x equals 0, y equals 1. Okay, here. And when y equals 0, x equals half at this point. So it means 2x plus y is equal to 1 is this line. 2x plus y equals 1. So clearly on this side, 2x plus y is greater than 1. And we have to consider only those points which fall in the support of x and y. So this will be all the points for which 2x plus y greater than 1. So it means we will have to integrate the PDF in this region and we will be able to find out this probability. But we can write it in another way also. Probability that 2x plus y greater than 1 can be written as 1 minus probability that 2x plus y is less than equal to 1. Notice here this equality sign does not make a difference even if we include it or exclude it, because x and y are continuous random variables, and for continuous random variables the probability that a random variable will take certain value, some exact value, it's 0. So the question is, why are we doing this? Why are we taking the complement? The thing is, if you try to integrate it in this region, what you will have to do, you will have to first integrate it for this region, this left region, and then integrate it for this region and add it up. For not getting into the trouble of two regions, we are just doing the complement 1 minus this small triangle area, triangle region, for which we have to integrate the PDF. So we can write it as 1 minus, this probability can be written as integration over this region of the PDF. What is the PDF here? PDF here is y by 2. First of all, what we will do, we will take small horizontal strip. We can take vertical strip also, that does not matter. Here there will be some particular value of y, and what are the coordinates of this point? It will be 1 minus y by 2 and y. So you pick some y, and with respect to y we are trying to calculate x, so it will be 1 minus y by 2. So y by 2 is the PDF. First of all, what we will do, we will integrate it over this strip, and this strip will go from y equals 0 to y equals 1, and the range for this strip will be from x equals 0 to x equals 1 minus y by 2. So we can write x equals 0 to 1 minus y by 2, and in the y direction we will add it from y equals 0 to y equals 1, and first we will integrate with respect to x, then with respect to y. So what we can do here is, we can first calculate this inner integration separately, and then we can put it there and find out that probability. So we have to integrate x equals 0 to 1 minus y by 2 y by 2 dx. So it can be written as yx by 2 x from 0 to 1 minus y by 2. So it will be y times 1 minus y by 4. When you put x equals 0, it just becomes 0. So this is the integration. Now we can put it here and integrate it further. So it will be 1 minus y goes from 0 to 1. 1 by 4 can be taken outside. Y times 1 minus y dy. So it can be integrated as y will be y squared by 2, and it will be y cube by 3, and we are integrating it from y equals 0 to 1. So 1 by 4, when you put y equals 1, it will be 1 by 2 minus 1 by 3, and finally when you put y equals 0, it will become 0, so we are ignoring that. It will be 1 minus, it will be 1 by 6, so 1 by 24. So finally you will get the value 23 by 24. So this is the probability that 2x plus y will be greater than 1. Coming to the 7th question, the joint density function of two random variables x and y is given as this. fxy of x comma y is 8xy when x falls in the range 0 and 1, and y is in the range 0 up to x only, and this PDF is 0 otherwise. And we have been asked if x and y are independent. So what we can do here, we have been given the joint PDF, and we have to conclude whether x and y are dependent or independent. So what we can do is, we can find the marginal PDFs of x and y separately and check whether the multiplication of the marginal PDFs is equal to the joint PDF. If that is equal to the joint PDF, so fxy at xy we have been given, and we will calculate fx at x, the marginal of x, and marginal of y. Okay. These both quantities, marginal of x and marginal of y, we will calculate and check if it is equal to this joint that we have been given. Then we will conclude that these are independent, and if these are not equal to this, then we will conclude that these are not independent. So let's calculate first the marginal of x. How can we calculate the marginal of x? For calculating the marginal of x, as you already know, we will integrate the joint PDF function over the full range of the other random variables. In this case, there is only one other random variable, that is y. So we will integrate it with respect to y over the full range of y. So y goes from 0 to only x. So we can do 8x y squared by 2. So it will become 4x y squared. And the range will go from y equals 0 to x. So in place of y, we will put x. So it will become 4x cube. And because when you put y equals 0, it becomes 0. So we are ignoring that. So this is the marginal PDF of x. Now let's find out the marginal PDF of y. So we will integrate the PDF with respect to the other random variable, that is x in this case. So x will go from, we will integrate it over the full range of the other random variables. So x will go from x equals 0 to x equals 1. So finally it will be 8x squared y by 2. So we can write 4x squared y integrated from x equals 0 to 1. So it will finally become 4y. So this is the marginal PDF of y. So let's try calculating the product of the marginal PDFs. So fx of x times fy at y, it is 4x cube times 4y, which is equal to 16 times x cube y. So it is not equal to 8xy. So we can conclude that fxy at x comma y, it is not equal to the product of the marginal PDFs fy at y. So it means these random variables x and y are not independent. These are dependent. In this question, we have been given two random variables x and y, which are uniform in the region D, where D is equal to this area, where x falls in the range 3 and 5 and y falls in the range 2 and 4. And we have been asked whether x and y are independent. So it's better to first visualize this situation. So okay, 0 1 2 3 4. So x goes from 3 to 5 and y goes from 2 to 4. So this area, three to 5, 2 to 4. So this is the support of x and y. In this region only, x and y take some value, and the values are taken with uniform probability, or the PDF in this region is uniform. So first of all, let's try to calculate the joint PDF of these fxy of x comma y. Since we know that these are uniform in this region, we can calculate the PDF in this region as 1 divided by the region of this area D. Okay, so what is the area of this region? It is equal to 2 times 2 4. So 1 by 4 is the PDF, uniform PDF, where x goes from 3 to 5 and y goes from 2 to 4, and it's 0 otherwise. In other regions it is 0. So we have the joint PDF of x and y. Now we have to verify if they are independent or dependent. Now it becomes a very easy task. Now we can calculate the marginal PDFs of x and y and check whether the product of the margin PDFs is equal to the joint PDF. If they are, then those are independent, and if they are not, then those are dependent variables. So we can calculate the marginal PDF of X here by integrating the joint PDF over the full range of the other random variable Y, and Y is going from 2 to 4. Y equals 2 to 4. It is equal to Y by 4, 2 to 4. It is equal to 4 minus 2 by 4, that is 1 by 2. So this is the marginal PDF of X. Marginal PDF of Y can be calculated as the integration of 1 by 4 dy dx, because we are integrating with respect to the other random variable. So X will go from X equals 3 to X equals 5. So finally it will be X by 4, X equals 3 to X equals 5. So 2 by 4, again it is 1 by 2. So both the marginal PDFs of X and the marginal PDF of Y both are equal to 1 by 2. So let's verify if the product of marginal PDFs, which is equal to 1 by 4, and the joint PDF at XY is also equal to 1 by 4. So both are equal. It means X and Y are independent. Coming to the ninth question, the joint PDF of two random variables X and Y is given as fxy of X, Y is equal to 4xy when X is in the range 0 and 1 and Y is in the range 0 and 1. Both are in the range 0 and 1. And it's 0 otherwise. We have to find the distribution of X given Y equals 0.5. So we have to find the distribution of X given Y is equal to 0.5. As we know, any conditional distribution can be calculated as the joint of the conditions or events. So in this case, what is the joint? Joint is nothing but the joint PDF, where X takes value X and Y takes value 0.5. And what is the marginal PDF of the conditioned event, okay, on which it is conditioned? So on what it is conditioned? Y equals 0.5. So it means we have to find the marginal PDF at 0.5 in the denominator and put it here. So in this way we will be able to find the distribution of X given Y equals 0.5. So the numerator is very simple. We just have to put these values in the joint PDF. We have to leave X as it is, and in place of Y we will put 0.5. But in the denominator we will have to find the marginal PDF of Y. So marginal PDF of Y we have to calculate. If Y at Y, we can calculate it by integrating the PDF with respect to the X random variable over the full range of X. So X will go from 0 to 1, 0 to 1. What we will integrate? We will integrate 4xy dx. So it will become 4x squared y by 2. So finally 2x squared y integrated from x equals 0 to x equals 1. So it will be just 2y. So this is the marginal PDF of y. Now when we calculate it at the point 0.5, it will just be 2 times 0.5, that is 1. Now we can easily calculate this conditional distribution. So 4x will be left as it is, and then in place of y we will put 0.5 divided by the marginal at 0.5, it is equal to 1. So finally it is equal to 2x. So this is the marginal PDF of X given Y equals 0.5. So the correct choice would be the first option. In the 10th question, we have been given the joint PDF of two random variables x and y is given by fxy at x comma y is equal to x squared plus xy by 3, where x falls in the range 0 and 1 and y is in the range 0 and 2, and the PDF takes value 0 otherwise. We have to find the value of probability that x will take value between 1 by 4 and 1 by 2 conditioned on y taking value 1. So y has already taken value 1, and in that case we have to find the probability that x will take values in the range 1 by 4 and 1 by 2. So this probability we will be able to calculate if we know the conditional distribution of x given y equals 1. So if we know this quantity, then we will be able to find any probability defined in terms of x. So the first goal should be to calculate this conditional PDF. So as you know, the conditional PDF of any random variables can be written as the joint of the events over which it is defined divided by the marginal of the event on which it is conditioned. So joint in this case can be written as the joint PDF at x taking value just x. We don't do anything to x, and then we put value y equals 1. This is the joint divided by the marginal on which it is conditioned. In this case it will be equal to the marginal of y at 1. So for calculating this, we need this joint of this, which we already know. We can find it out by putting the value of y equals 1, but we will have to find out the marginal of y. So the marginal of y, fy at y, can be written as the integration of the PDF x squared plus xy by 3, and we will integrate it over the full range of x. So x goes from 0 to 1. It will become x cubed by 3 plus x squared y by 6. So x going from 0 to 1, which will be equal to 1 by 3 plus y by 6. So this is the marginal PDF of y, but we have to find out the marginal PDF at 1. Marginal PDF of y at 1. So it will be 1 by 3 plus 1 by 6, which is equal to 3 by 6 or 1 by 2. So now here we can put the values and get the conditional distribution of x given y. So we can write it as x squared plus putting the value of y equals 1. We will get x by 3 divided by the marginal of y at 1, which is 1 by 2. So it will become equal to 2x squared plus 2x by 3. So this we have found the conditional distribution of x given y equals 1. So now we will be able to find out any probability which for which the events are given in terms of x. But here we have to find this probability that x will take values in the range 1 by 4 and 1 by 2 given y equals 1. So it will be nothing but the integration of this conditional PDF fx given y equals 1 dx. We will integrate it with respect to dx, obviously. So it will become, and we have to integrate it from x equals 1 by 4 to 1 by 2. So we can write it as equal to probability x taking value between 1 by 2 and 1 by 4 given y equals 1 as the integration. What we will integrate? We will integrate the conditional PDF, that is 2x squared plus 2x by 3. Can take the 2 constant out and we can write it as x squared plus x by 3. Integrating with respect to x. So it will become x cubed by 3 plus x squared by 6. Integrated from 1 by 4 to, which can be written as 2 times 1 by 24 plus 1 by 24 minus 1 by 192 plus 1 by 96. So it will be 1 by 12 minus 1 by 64. So this is the probability that x will fall in the range 1 by 4 and 1 by 2 given y equals 1. So the correct choice would be the second option.